Let's look at problem number 5 here. At what point does the normal to curve at -1 point intersect with the parabola a second time? Well, clearly, if you have a curve, you can have a point, it has a tangent line, normal line is the one perpendicular to it, right? Depends on the way the equation looks like. For example, I have a parabola, I have a tangent line, I have a normal line. This normal line intersect at the curve at this point, and it would intersect at that point. So how do I find it? Well, if I know the equation of a line and the equation of the curve, if they were to go through the same point, it means the x and y value will be the same. So I'm going to solve a system of equation. Well, let's try to work that one out. Let's find my normal line first. In order to find my normal line, I need to find my slope. And the point is given to me 1, -1. So what's the slope? In order to find the slope of a normal line, I need to find the slope of a tangent line. So I need to take the derivative of the function, which is hopefully straightforward. So you have 6x minus 3 as the derivative, but this is not the slope of a tangent line. You need to say at the point, x being 1, then you have 6 times 1 minus 3, which is 3. Okay, so this is the slope of the tangent line. Therefore, the slope of the normal line is -1/3. So your line is supposed to be y minus -1 equals -1/3 times x minus 1. So we have repeated many times in class. In this course, the best idea is to try to use the point slope formulation. It's much more easier to manipulate. Well, because I do have other calculations afterwards, so I could have simplified it a little bit, but it's not required. So I have my normal line, it should intersect with my curve. So two of them should be satisfied simultaneously. So I should be having y equals 3x squared minus 1 plus 3x. So I have a system of equation where I have two unknowns, so I should solve both of them simultaneously. Well, the second one equals y, so I can make the first one look slightly prettier. I add the -1 to both sides, so it's equals -1/3 x plus 1/3, and I add -1, so it's -1, so it's -1/3 x minus 2/3. So they are both equal to y, so this expression and that expression, they are supposed to be the same. So let's carry out my calculation. I have 3x squared minus 3x minus 1, that's this expression here, equals -1/3 x minus 2/3. So I end up with 3x squared minus 3 plus 1/3 means minus 8/3. And then minus 1 and plus 2/3 means minus 1/3 equals 0. This is a quadratic equation, so you can try to use quadratic formula to solve it. But also, I know that this point, x being 1, is going to be one intersecting points between the normal line and the curve. So x equals 1 makes this equation to be 0 to be true. Therefore, x minus 1 must be a factor of it. Therefore, I need another factor, which is 3x, so I can find 3x squared. I also need a 1/3 to form the -1 times that gives me this. So I can take a quick look if my factor makes sense. So I end up with 3x squared minus 3x, and then plus 1/3 x minus 1/3 equals 0. So yes, my factoring does make sense. I'm doing this correctly. So I'm going to say that means x equals 1, which is a given point, and x equals to -1/9, right, is my other solution. If x equals 1/9 is the solution, then I'm going to plug it back either into this quadratic function or into that linear function because they are going to intersect. So they are going to satisfy the same value at the same time. So y equals -1/3 x minus 2/3, namely -1/3, -1/9 minus 2/3. So this is my value, the y value. This is my x value. So putting two of them side by side is going to give me the Cartesian coordinate of the intersecting point for the line, the normal line of this function and the function itself.